Hi everyone, Octdirect here. In this video, I'm going to cover how to improve Geometry Dash's performance. We'll look at in-game settings, at Steam, and at some options and tools available on both the Windows and Linux operating systems to give you a better playing experience. This video is a long one, so check out the list of timestamps in the description if you're in a hurry. Without further ado, let's get started. Before discussing any tips, I want to first dispel the rumor that GD only uses your CPU. Here I have Geometry Dash open, and now I'm going to open Task Manager on Windows and go to the Performance tab. Here you can see my GPU's utilization. You can see that my GPU is being moderately utilized right now. Then, if I close GD, then you'll notice that my GPU utilization suddenly drops, indicating that GD was in fact using my GPU. And if you're wondering about OBS, it's minimized, so my GPU doesn't need to render anything to display on it. Also, I'm using my CPU to encode this video, so there's almost no additional load on my GPU from OBS. The fact is, like most games, GD uses both the GPU and CPU. Now, if you only have integrated graphics, then your GPU is a dedicated part of your CPU, and that means you'll generally have weaker performance on any game you play because the CPU and GPU have to share power and cooling capacity. If you have a dedicated GPU, however, then you'll generally get better performance than somebody with an integrated GPU, unless you have a very old GPU and the person you're comparing against has a new CPU. Admittedly, my GPU is old enough that some integrated GPUs can outperform it now. Anyway, it is, however, true that GD oftentimes is bottlenecked by the CPU. Like many games, especially older games, GD only uses a single core of your CPU. Once GD maxes out the performance of that one core, it doesn't matter how beefy the rest of your system is. GD will start lagging. Nothing is Scary made an excellent video discussing the matter, and I suggest checking it out if you want to learn more. Before we move on, I should mention that if you have both an integrated GPU and a dedicated GPU, or even more than one dedicated GPU, then your operating system is making the choice for you as to which one you use. You are going to have to override it if you are not getting the results you want. On Windows, for example, you can go to the System Settings, click on the System section, and then scroll down to the Display page, and then click on Graphics Settings. Here you can use the Browse button to add programs, which you have to do by finding their actual .exe file. Here's the path for Geometry Dash. Once a program has been added, you can click on it, and then select Options, and then you can decide what you want to do. Here on my system, I only have the NVIDIA GPU, but it provides two different power profiles. As for Linux, hybrid graphics has traditionally been a pain point, with support for specific hardware configurations being hit or miss, and the method of switching GPUs when supported being different on different distributions and desktop environments. It's kind of a mess, so I won't be getting into it here. Now that we know that GD does use one's GPU, but is frequently CPU bottlenecked, we should start looking into how to optimize the game to reduce that bottleneck. The first place we'll look at is the graphics settings, starting with window resolution. Window resolution is actually very important for in-game performance, with smaller windows generally performing better than larger windows. The reason for this is that a smaller window contains fewer pixels to render, so it's less graphically demanding than a larger window. Back when I used a low-performance laptop to record GD videos, think back to when my videos had a Bandicam watermark on them, I would reduce the size of GD's windows to reduce lag. Graphically heavier levels required a smaller window to get the game to run well. Of course, this came with the penalty of lower quality videos, as the recording software had more upscaling to do to create the same video resolution. Anyway, I recommend finding a window size that generally works best on most levels and sticking with that. Next is the texture quality. Texture quality also affects your game's FPS, and it can affect load times too. You should try to fit your texture quality to your window size. For example, if you can afford to play GD in full screen, you probably want to use the high texture quality. On the other hand, if you use a small window to play GD, then you might want to use the medium or low texture quality, as you are unlikely to notice higher texture quality on a smaller window. This also comes with the benefit of combining optimizations to get even more performance for your game. One thing to note is that back in 2.2, texture quality actually affected game physics. There's a level called Clutter Factory that had a section that was only possible with high detail texture quality. When 2.1 came out, texture quality stopped affecting game physics and the level became totally impossible. Thanks to the work by Pause in collaboration with RobTop, the bug in Clutter Factory is fixed, so you can beat the level now. Next, in the advanced section, we'll talk about vertical sync. This really could be its own video, but here we go. The purpose of vertical sync is to eliminate screen tearing. Here's how it works. Suppose that you have a 60 Hz screen. Every 60th of a second it has to draw a frame, and it does so from left to right, line by line. That will take a certain amount of time, and then the remainder of the time it will rest. This rest is called a V-blank. The goal of vertical sync is to make the GPU give a frame to the screen during this V-blank. If the GPU were to give a frame to the screen while it's drawing, then the picture on the screen will contain part of the old frame and part of the new frame. In something like a game where we perceive motion across many frames, the break between the old and new frames can be very distracting, and we refer to this as screen tearing. By providing the frame during the V-blank, one and only one frame is drawn during each screen refresh instead of half of one frame and half of another. Of course, this doesn't always work as planned. There's a bunch of other software that a full frame of the entire screen must typically pass through that can either correct or upset this timing. These are things like window managers, compositors, drivers, and firmware. As a result, you might never see screen tearing, or you might find that vertical sync is ineffective at mitigating tearing. For example, if the system's graphics stack delays the game's vertical sync timing, then the frame will finally reach the screen while it's drawing instead of during the V-blank. Conversely, your graphics stack could hold frames until the V-blank so that games and applications don't have to worry about synchronizing to the screen at all. It largely depends on the software of your operating system. The important part of vertical sync for Geometry Dash, though, is that it causes the game's frame rate to match the refresh rate of the screen. If you have a screen with a refresh rate other than 60 Hz, then turning on vertical sync will cause Geometry Dash to run at that frame rate instead of 60 FPS. The reason this is important is because Geometry Dash is designed to run at 60 frames per second, and like most games, it checks for input and performs calculations every time it creates a frame. This is known as a game loop. If GD relied solely on this game loop, then turning on vertical sync on a 120 Hz monitor, for example, would cause GD to run twice as quickly. Sonic Adventure 2, which is a game available on Steam, is an example of a game that behaves this way. For Geometry Dash, however, that does not happen. Instead, GD's game loop checks the system time or relies on another game loop that's independent of the frame rate so that the game logic does not speed up or slow down, regardless of what the frame rate happens to be. So how does vertical sync affect GD? It does so in two ways. First, by calculating physics more or less frequently than normal, sometimes the level will behave slightly differently from how it would at the usual 60 FPS. Second, and most importantly, GD will check for input more or less often based on the refresh rate of the screen. Let's compare 60 FPS with 120 FPS. Here we have a timeline with a sequence of frames. The time between each frame is 16 and 2/3 milliseconds, which means that the frame rate is 60 frames per second. The red bar represents a click that lasts 50 milliseconds. We can see where it starts and ends, and it's offset from the input check for each frame. For the first frame, the game has not yet realized that a click has started, so physics are calculated as if the player had not clicked. The second frame is then calculated as if the player clicked, and so are the next two frames after it. Upon the last frame, the game realizes the player is no longer holding down the mouse button, so it calculates physics without the player clicking. As we can see here, the player was actually clicking for the majority of the time during the first frame, but the game treated it as if there was no click. The same is true for the release. The player released early in the frame, so the majority of the time during that frame the game thought that the player was holding, when in fact they were not. You can also imagine what would happen if we reduce the click length to 46 milliseconds. Before, the player's input was counted for 3 frames, but now, despite only being slightly shorter, the position of the click relative to the input checks cause it to last for only 2 frames instead of 3. But let's go back. If we now analyze the 50 millisecond click at 120 FPS, we can see that the game's handling of input is closer to what actually happened. There is less delay for both the start of the click and the release. And for the shorter 46 millisecond click, it cuts off at the same place on both 60 and 120 FPS, but it's picked up sooner on 120 FPS and is therefore closer to the true duration. This is what makes Geometry Dash easier on higher refresh rate monitors. The game is more in tune with what the player is actually doing. While it seems like a minute thing, gameplay in GD very quickly becomes precise enough for this to affect players. Game modes like the ship and wave are affected most because they take into account both the start of the click and the release at the end of the click. To look at it from a more human perspective, the player is completely unaware of how their clicks line up with the game's frame timings. Therefore, we can think of the offset for a player's clicks relative to the game's input checks as being random, and that means that the perceived input delay is random too. The amount that this random delay is able to vary is based on the game's FPS. As you can see, there's twice as much room for the delay to vary in the 60 FPS track than on our 120 FPS track. This additional slop is what makes playing a level at 60 FPS harder than playing it at a much higher FPS. Therefore, if you increase the FPS, then you reduce the slop in accounting for inputs, and that makes the game easier to control precisely. For GD, precise control is an absolute necessity, so it's no wonder that players can accomplish more when they run the game at a higher frame rate. So it sounds like vertical sync is only good for Geometry Dash, right? Well, not exactly. First, unless you are just trying to address screen tearing, vertical sync only does something if you have a screen with a refresh rate other than 60 Hz. Of course, you can spoof your screen's refresh rate, but that's not a topic I'm going to get into here. Second, as I mentioned earlier, calculating a game's physics at a different rate can cause the game's physics to behave differently, which can break some levels. Third, if you run GD at a higher FPS, then you will need a more powerful GPU to render the additional frames, and that also applies to the single core that Geometry Dash is running. Let's say that you turn on vertical sync with a 120 Hz monitor, making GD want to run at 120 FPS. If you play a computationally demanding level that drops your frame rate down to approximately 90 FPS, it will generally be a rougher experience than if you turn vertical sync off and play the level at 60 FPS. This is because the actual FPS of the game is fluctuating, which Geometry Dash was not designed to handle nicely. This is the reason that Carmel, or KR-Mal, Crazy Man 50, you know who I'm talking about, verified Black Blizzard at 60 FPS despite owning a 144 Hz monitor at the time. And fourth, there have been reports of vertical sync adding random delay to players' clicks, even in spite of how, as we just discussed, high refresh rate displays increase the accuracy of input processing. Despite these possible downsides, the benefit for players with high refresh rate displays is enormous, and game modifications notwithstanding, players almost always use vertical sync when they have the appropriate hardware. Before I move on from vertical sync, I want to circle back and discuss the rumors that it adds random input delay. The cause of this is not known, but there are a couple of possibilities. First is frame caching. There is a possibility that vertical sync causes an extra frame to be stored so that if a frame ever takes too long, that spare frame can be sent to the screen instead of having a frame drop. Then the game tries to catch back up. In this example, I show the idea for a whole frame being cached, but it could be half a frame, 2 frames, or however many frames fit within a certain time span. You get the idea. On its own, a frame cache will add a fixed amount of latency that is easy for a player to compensate for. However, if a lag spike occurs, then the subsequent input check could come late, ignoring whether the player clicked or released during the lag spike. Thanks to the frame cache, though, the lag spike, if it isn't too severe, is covered up, making the issue invisible to the player. While we don't have any confirmation of the existence of a frame cache, it could make sense for vertical sync to include this as a safety net. After all, the most significant effect of vertical sync is that it can increase the frame rate of the game, which would place a greater computational demand on the GPU and open the door to having more missed frames. Of course, vertical sync increasing GD's FPS on high refresh rate displays caught RobTop off guard in 2015, so using frame caching as a safety net for higher FPS would not have been his idea. But what if GD's vertical sync was more a feature of the game engine rather than something RobTop made himself? Again, it's possible, but all we have is speculation to go on. The other possible explanation for the additional input delay caused by vertical sync actually lies in our next performance option, Smooth Fix. As you are playing GD, there can occasionally be a frame that takes longer to render. This can result in the game suddenly lurching forward without checking for input during the additional time between frames, and it can lead to further delays as the game attempts to catch back up. Not only is this a rough player experience, but it can also cause the player to crash. SmoothFix attempts to smooth over this by pausing game time so that the game does not lurch forward. Instead, once the frame is done, the game loop continues as if that frame never fell behind schedule. Basically, enabling SmoothFix allows a timeout to be called if a frame takes too long to render so that the frame can finish rendering without subsequent frames falling behind schedule. SmoothFix is not a perfect solution for a couple of reasons. First, it does not account for the fact that the song in a level just keeps playing. In fact, if the song was paused too, then players would certainly notice SmoothFix in action because the break in the audio would be much more obvious. Because the song is not paused with SmoothFix, over time, a level's gameplay can fall behind its song. This is actually something I noticed when recording some of my first videos for this YouTube channel all the way back in 2016. The other reason SmoothFix is imperfect is because it can still cause the player to crash. To provide an example of how, suppose you're playing a section that requires very precise muscle memory. If there was a small delay in time caused by SmoothFix in the middle of the section, then you would have to wait or hold just a little bit longer to compensate. This can throw off your muscle memory, causing you to crash. Of course, a frame drop can also cause you to crash, but if you didn't need to click or release exactly when the frame drop occurs, then you'll be fine, provided that you are not visually distracted by the frame drop and physics don't bug out. Again, this is because, with a small frame drop, in-game time never stopped. So now that we know what SmoothFix is, let's talk about how it relates to vertical sync. When a person with a high refresh rate display uses vertical sync, their FPS will increase to match the display's refresh rate. As a result, the GPU will have more frames to compute and less time in which to render them. This makes dropped frames more likely. When SmoothFix pauses the game to address a dropped frame, it can mess up muscle memory like we just discussed. With an increased likelihood of experiencing dropped frames at a higher FPS, SmoothFix might be coming into effect more often, giving the appearance of additional random delay to one's inputs. Furthermore, I could see some players enabling vertical sync and SmoothFix at the same time because they're right next to each other in the advanced graphics settings menu. However, even if a player left SmoothFix on the whole time, they are more likely to see it come into effect with vertical sync on while using a high refresh rate display. Disabling SmoothFix while using vertical sync, therefore, is recommended. In fact, I recommend disabling SmoothFix regardless of whether you use vertical sync or not. However, if you have an underpowered device, SmoothFix might be necessary to have a reasonable playing experience. Just play without it and see if the experience is tolerable, and then turn it on if you regularly run into lag spikes on graphically simple levels, like those made in 1.9 or before. Our next setting is Low Detail Mode, which is located on the Help menu. Low Detail Mode completely disables particles, disables colored flashes when you hit pads and portals, disables the gravity switch effect in which faint lines move across the screen in the direction of gravity, and it disables a small effect that orbs display when the player enters their hitbox. It has a negligible effect on performance, and because of how much stuff it disables, I have a hard time recommending it. Let's start with the orb contact effect. When the player passes through an orb, a small effect is displayed showing that the player entered the orb's hitbox. This effect shows up even if the orb is completely invisible. This can be a very helpful clue for finding user coins or other secrets hidden in a level, and Low Detail Mode completely deprives you of that information. Next, the missing particles actually change levels quite a bit. As you can see in the background footage, creators use particles to decorate their levels, and some even use particles to provide gameplay-specific information to the player. If you turn on Low Detail Mode, you will lose all of this. And last, and perhaps most important, is the lack of orb, portal, and gravity effects. Back in 2017, I made a video discussing the Noctifly situation, and one of the key points I brought up was that he was using Low Detail Mode in his recording of Sonic Wave. In the background footage right now, we have two side-by-side runs of Sonic Wave. Both are auto, but it's hard to determine when looking only at the low detail version because the Low Detail Mode hides gravity changes. After Noctifly was exposed hiding level modifications with Low Detail Mode, videos recorded with the feature enabled have been viewed with suspicion ever since. Basically, if you plan on making YouTube videos, you should keep Low Detail Mode off so that people don't suspect you of cheating. I just can't recommend it for anyone playing GD in any competitive or serious fashion. However, if you have a very low performance device, it might be able to provide some benefit, so you'll have to experiment with it and see if it's actually worth using. Now let's move on to the main set of options, starting with high capacity mode. This option is the least understood in the community, and that's due to the very technical language in its description. To understand this, I had to do some research on how GPUs render games and view some documentation and discussion on GD's game engine. The idea behind high capacity mode is that GPUs render things most efficiently in batches, similar to how we bake cookies. Rather than measuring ingredients, mixing them together, and then baking the dough one cookie at a time, we perform each step across an entire batch of cookies. Similarly, it's far more efficient if a GPU renders, for example, all of the outlines for a set of blocks before trying to render the textures of the blocks. This is where a batch node comes in. A batch node groups the things that should be rendered together so that the GPU can be told the most efficient way to render everything. Now, as for draw capacity, it turns out that as visual objects are added to a batch node, it will occasionally have to recompute some data for all of its contents, for example, placement coordinates. Therefore, if the program assumes that the batch node will be very large when it creates the batch node, then less computation will be needed to be done because the batch node is not constantly changing size, at least for a while. By turning on high capacity mode, you are telling GD that the batch nodes it uses should be created with a high initial capacity to avoid recomputing some of the data grouped inside of the batch nodes. This can improve the game's performance, but just at the start of the level when the batch nodes need to be created for the first time. And this is very telling of the feature's impact. If you like at the start of your first attempt, you can just crash and then play well on the next attempt. After the very start of the first attempt, the window of opportunity for high capacity mode to help you is over. Therefore, this setting is realistically not very important, but at least you now understand the idea behind it. Okay, but what about the warning for low-end devices? While I'm not entirely sure, my guess is that on very low-end devices, you could unnecessarily fill up the integrated GPU's video memory, which would degrade performance rather than improve it. And when I refer to video memory, I'm also referring to cache in the processor's die as well. Processors are so fast at handling data compared to memory that they have multiple levels of cache, a faster type of memory, to help funnel data out of the slower memory and into faster cache so that the processor has data available to it as soon as it needs it. So my hypothesis here is that larger batch nodes would take up more space initially, which could bottleneck the data funnel to the GPU with empty data and force the GPU to wait for more useful data to enter video memory and cache. If your GPU has more video memory, bigger caches, and the memory is newer and runs faster, then this bottleneck will not occur or it'll be harder to notice. But again, this is just a hypothesis. I did a bunch of testing and was unable to find any noticeable difference in memory usage or performance from using high capacity mode. But like I said earlier, it's only supposed to help at the very start of the level, so it's not a big deal anyway. Okay, so we are finally done with the complicated settings, so now we can quickly go through the rest of the settings here in GD. That does not mean they're unimportant though, just that they require less explanation to understand. First, load songs to memory tells GD to load the entire song for a level into memory before it starts the level. This can improve performance as you are playing a level, particularly if your hard drive is busy, but it makes the level take longer to start. If you are speedrunning, yes, GD speedruns exist, then you want to have this setting turned off, but otherwise it's a good thing to have on. High start position accuracy can reduce performance, but it makes the game behave more consistently. Turn this off if you're having problems starting levels from start positions. Change custom songs location makes GD download songs to your Steam folder rather than to your app data folder. See my video about a backup tool I made for GD for more information about these folders. Next is force smooth fix. We discussed smooth fix earlier in the context of the occasional single frame drop. However, when a level is very graphically demanding, so much so that GD is unable to maintain its target FPS, then smooth fix will disable itself. Again, the target FPS is either 60 frames per second or whatever the refresh rate of your screen happens to be when using vertical sync. The reason smooth fix turns off here is because it would cause the game to slow way down. For example, if GD normally runs at 60 FPS, but a part of the level lags and causes GD to drop to 40 FPS, then with smooth fix working the whole way, that part of the level would play at 2/3 its intended speed. This would create massive desync between the gameplay and the song, and the level would play almost like you have speed hack turned on. Force smooth fix, as its name implies, forces smooth fix to remain on, creating that speed hack effect. There have been players taking advantage of this by making their PC perform poorly and then playing difficult levels with forced smoothfix turned on. Technically, that's cheating, and I discourage people from doing that. However, sometimes smoothfix does not work well enough, so forcing smoothfix can be helpful for particularly harsh lag spikes. Next, disable explosion shake turns off the screen shake effect that occurs when you crash. This can improve performance slightly. Disable shake effects can also improve performance as it causes GD to completely ignore shake effect triggers. In general, I want to experience what creators intended for their levels, so unless I encounter a level that just abuses shake triggers, I keep the setting turned off, as you can see. Next is a very minor one, and that is show percentage. Basically, the percentage indicator and even the progress bar are both extra things for the game to render, so if you remove them, there is less for your GPU to do. I think personal preference trumps whatever minuscule performance gains you might hope to obtain, but I've included show percentage here for the sake of completeness. Fast practice reset makes practice mode jump to the next attempt in half the time. If you are lagging at the start of practice mode attempts in a level, then you could try turning this setting off to give the game more time between attempts. I don't like it because I sometimes feel like there is already too little time between attempts, but there could be a performance benefit to that decision too. Practice death effect is another setting that you want to have turned off for optimal performance. Obviously, if the game needs to render a death effect in practice mode when you are dying often, then that is going to come with a performance hit. The only thing of note on this third page is the disable gravity effect. This one is one of the effects disabled by low detail mode, specifically the one that sends the lines up or down the screen with the gravity change. On its own, there's nothing wrong with disabling this effect, and it could result in a very small performance increase. Because orbs and pads still have their effects, it doesn't come with any of the downsides of using low detail mode that we discussed earlier. Therefore, this one really is just a matter of personal preference. Of course, your video might still look a little bit suspicious with some effects on and some effects off. Here on the fourth page, no song limit, as its name implies, removes the limit on the number of custom songs you can have downloaded. This is sort of a performance feature because you won't have to wait for songs to download if you've ever played a level with that song before, you won't create extra disk writes, saving a song more than once, and you will slowly build up a large collection of Newgrounds songs on your hard disk. Having a lot of songs won't necessarily slow down your system unless your drive is almost full, and then that becomes more of an issue for your entire operating system than just for GD. Enable move optimization increases performance, but it can cause some visual glitches. I've never seen anything weird happen with moving objects, so it's basically a free performance increase. Increased max undo and redo will use slightly more memory in a level editor, but if you need it, it's probably indispensable. On a very resource-constrained system, I could see somebody needing to turn it off, but they probably have performance everywhere else too. Here on the last page, SmoothFix in Editor applies to the feature of the editor where you can play your level without leaving the editor. This can be handy because test play performance is not very good, but like with regular SmoothFix, it can cause the song and the gameplay to get out of sync, so use with caution. So now that we have finished covering the settings currently available in GD, I figured we could also talk about the settings that are expected in 2.2. We actually have some of these settings available in Geometry Dash Meltdown, Sub-Zero, and World, as these spin-off games have received some 2.2 features ahead of the main edition of Geometry Dash. Now, I do understand that 2.2 coming out is a bit of a meme, so feel free to skip this section if you're not interested in 2.2 performance. The first thing we should talk about here is actually what's missing. In RobTop's videos showcasing level editor features for 2.2, he shows off an FPS counter, and it's almost pegged to 1000 FPS in 3 of his videos. It looks like we will have an option to increase the game's FPS without needing a higher refresh rate monitor. There are no settings in the spin-off editions of GD for this feature, however. In fact, the graphics menu is just completely missing, so we'll have to wait and see how everything will work. Allowing players to freely change their frame rates will likely come with some physics changes, and RobTop has talked about this in the past. It's likely that some settings might need to be added for legacy physics as a workaround for bugs on some levels. What kind of performance implications that might have are yet to be determined. Alright, so let's take a look at the settings that we do have. First is Fast Editor Preview. This likely refers to animations in preview mode. In the video showcasing the new particle editor, we can see from the blue background that RobTop has the editor in preview mode, and here the particle object that RobTop created is animated. If we read the description on Fast Editor Preview, we can see that the default playback speed is 20 FPS. This likely refers to the preview mode when you are editing the level rather than playing it, because playing at 20 FPS would not be a great experience at all. Next is Auto Low Detail. This just automatically checks the low detail mode checkbox that levels can have as of 2.11. On the next page, we have Don't Save Level Data. This can make it so that you cannot save user-made levels locally to play. It can make saving your game data go much faster, but you'll need an internet connection to play any user-made levels at all, because every time you load the game, you're going to have to re-download those levels, even if you put them in your save folder. Save Gauntlets is similar, but in reverse. If you find yourself coming back to Gauntlet levels, you might want to turn this on so that you don't have to re-download them over and over again. And then on the next page, our option is Unlimited Checkpoints. This setting is a new idea to most of us because GD currently has unlimited checkpoints. If you spam checkpoints, you can just undo all of them and work your way back to the beginning of a level. However, in 2.2, it looks like the default behavior will be to limit checkpoints to 20. If you place down more than 20 checkpoints, then only the last 20 will be saved. If you delete all of these, then you'll end up back at the start of the level, still in practice mode. So the performance implication here is slightly more memory usage to store more checkpoints, provided that you need more than 20. Moving on, music in practice could negatively affect performance because each death in practice mode will force the game to move through the song and restart it at a certain spot based on where the checkpoint is. While you may think that this still happens on a normal mode attempt or with the start position, the game currently only needs to keep track of one position in the song to restart to. If lag at the start of each practice mode attempt becomes a problem in 2.2, then this would be a setting to disable. Next, for detailed info, it shows some debug stats at the top left corner while playing a level. There probably isn't a big performance impact for this, but I also can't really recommend playing with that info unless you're testing or creating levels. Now let's talk about hide attempts and hide attempts practice. These two just hide the attempt count in normal and practice mode respectively. There is not a huge performance impact from these, but having less stuff to render is always going to be more performant. Here on the last page, extra low detail mode is interesting. What it does is it removes glow from levels, but only when you check the low detail mode checkbox on the level page. It adds to whatever the creator did for low detail mode. If a level does not have that checkbox, then a new checkbox is created called LDM Light. I will admit that it can be difficult to see this feature do anything, but it's another thing that you can use if creators don't provide effective enough low detail modes for their levels. Hide Portal Guide and Show Orb Guide probably don't affect performance because they should just swap out the object textures used in games. And finally, higher audio quality, I'm pretty sure, is not a new setting. I think it's just exclusive to mobile, because I swear I've seen it before. Anyway, this could reduce performance a little bit because the audio will require more computation, but it shouldn't be significant. Now that we have finished covering in-game settings, I want to look at some options in Steam that can help with performance. If you use Steam on multiple operating systems, you will need to perform these steps on each one, as Steam does not synchronize its settings across your installations. Also, if you have Family View enabled, you'll need to step out of that now. From the Steam menu, we can access the Settings menu. If we then go to the In-Game tab, you will see an option for FPS counter. This is helpful for testing performance settings and even showing your FPS in videos. Do note, however, that the FPS counter can sometimes overestimate your FPS or suggest that your FPS is more stable than it really is. If you use OBS to record, you will need to use a window capture instead of a game capture for the FPS counter to appear in your recordings. One thing to be aware of, though, is that there have been reports that this FPS counter can cause input delay or performance degradation. I have never noticed any issues, and you can see from my videos that I do play with this FPS counter, but it's still an important warning if you are chasing the absolute highest performance. The other Steam setting of interest to us is in the Library tab. If you leave Steam open while playing GD, then you should check this option here called Low Performance Mode. This reduces the graphical demand that the Steam library will put on your system, freeing up more processing power for your games. Now let's transition to some things we can do on Windows to improve performance. There's a lot here that I could cover, like GPU drivers, global GPU settings, shutting down background processes, and preventing unneeded programs from running a startup. However, these are all topics that are covered better by other tech videos on YouTube. Instead, I just want to focus on power and process priority for this video. For the general debloating of Windows, I suggest checking out videos by Mental Outlaw or Chris Titus Tech. First, let's look at game mode. Game mode should be on by default, but to check its status, open up the Windows settings, and then go to Gaming, and then click on the game mode in the sidebar. Game mode does two things on your system. First, it makes Windows prioritize programs it determines to be games while deprioritizing background processes. And second, it holds back restart notifications for system updates. Neither of these are perfect though. Windows updates still force themselves on you even if you just want to shut down your system without updating, and games can still be set to an even higher priority for greater performance. However, game mode is a good starting place. Next, I want to discuss power profiles. There are two ways to access the power profiles menu. The most direct way is through the control panel. Just look for the power options link and it will take you right there. Of course, knowing that Microsoft has been trying to phase out control panel for a long time now, I'll show the other way through the Windows Settings app. We go into System and then choose Power and Sleep in the sidebar, and then we click on Additional Power Settings over here on the right, and then we arrive at the same place. Regardless of how you got to this page, what you want to do here is choose the high performance power plan. If you see more than one, like I do here, then just ignore the additional plan section. For the most part, that is all you need to do. However, you can also click on Change Plan Settings and fine-tune the power plan. Then, if you click on Change Advanced Settings, you'll have access to the rest of the available options. One more power-related thing I want to discuss is specific to laptops. Sometimes, seemingly out of nowhere, you can get very poor performance in games and even other applications on a laptop. This can even persist past reboots, and it's actually happened to me a couple of times. The surprising answer that I found that can address this issue is to unplug your laptop and plug it back in. Yes, really, it sometimes is that dumb. What can happen is the performance management side of Windows can sometimes get confused as to whether the laptop is plugged in or not, so it decreases performance because it thinks it's conserving your battery. This can even happen if your battery is completely dead, like if it no longer stores a charge at all. Unplugging and replugging your laptop can update this part of Windows, allowing your system to perform to its fullest again. It's definitely something that you want to write down in a troubleshooting document or something like that, just because of how weird it is. The last thing we can do on Windows to improve GD's performance is to increase GD's process priority. The way you can do this manually is by opening Task Manager with Control, Shift, and Escape at the same time. Now, if this is all you see, click on the More Details button. Now all we have to do is find Geometry Dash, right-click on it, and click on Go to Details. Then we can right-click on Geometry Dash again and set Priority. And here we can choose High. Then you're good to go. For the remainder of the Geometry Dash is open, it's going to run at a higher process priority, which means that it's going to have the CPU first when it needs to have CPU access. As I mentioned, this only works until you close GD. Windows will not remember this every time you start the game, and going through this process every time you want to play is a bit annoying. So what we're going to do is write a script that accomplishes the same thing using shell commands so that we just have to run the script when we start GD. I also want to quickly mention the work that Zanny has done in this area. He created a Python script that increases GD's priority and decreases Discord's priority. Generally speaking, though, it's better if you can do something using your operating system's tools rather than through a general programming language. So that's why I'm covering this topic, even though a solution already exists. So let's close GD. Our first step is to decide where to store the script. I keep a folder in my Documents folder where I like to store executable scripts. But the exact location where you keep it doesn't really matter. The first thing you need to do is right-click where you want to keep your script, hover over New, and then choose Text Document. From here you can give it a name. The name doesn't really matter, but something like GD Priority makes a lot of sense. Next, we want to open it up with a text editor. In this case, I am using a Notepad++, but if you don't have that, Notepad will work as well. From here, you want to paste in the commands that I left in the description. The first command here turns off terminal feedback, because this is just going to run really quickly and then go away. The second raises Geometry Dash's process priority. You can see it uses some SQL-like syntax. And then the third line decreases Discord's process priority. If you don't have issues with Discord, then you can leave out this third command. Once the commands are in, press Ctrl and S at the same time to save, and then exit your editor. Next, if you don't have file extensions enabled, you will need to enable them. In File Explorer, click on the View tab, and then on the checkbox over here for file extensions. Let me re-enable that. Now, we need to right-click on our text file and change the file extension from .txt to .bat. That stands for batch file. Now, you will get a warning about changing the file extension. Just accept that and say yes. And then once that's done, we need to right-click on the file and then choose Create Shortcut. This shortcut is what will be used to run the batch file. Now we need to get the shortcut to its proper home. You could just place it on your desktop, but to get into your Applications menu or activate it with a keyboard shortcut or pin it to your Start menu, we need to move it manually into the Start menu folder. To do this, select the shortcut file and then press Ctrl and X at the same time. This will cut the file. Then, in File Explorer's address bar, we'll want to type in %appdata%. Notice that we are not going to local app data like we did in the previous videos. Press Enter, and then we need to go into Microsoft, and then Windows, and then Start menu, and then Programs. And here we can press Ctrl and V at the same time to paste. You can also rename the shortcut to something a little bit nicer. Now this is where we cover some optional steps. If you want an icon for this shortcut, I provided a download link in the description for this video. It's just a basic edit of GD's icon. Once you download it, you want to place the icon in a permanent home for custom icons. I've got a folder here inside of my Pictures folder. Once you get the icon into place, let's go back to the shortcut in our Start menu folder, right-click on it, and then choose Properties. Then click on the Change Icon button. Then we want to click on the Browse button, and then in the next window we want to navigate to the location where we have our icons. And then we'll choose the icon that we want to use. Finally, click on OK, and then click on Apply, and you'll see that the icon has changed in the File Explorer window. In addition to an icon, we can set a keyboard shortcut. Just click in the text box and press the keyboard shortcut you want to use. Personally, I like Ctrl, Alt, and G at the same time. Then click on the OK button to confirm the changes. The next step is to reboot, as Windows will not detect the new shortcut automatically. Once we're back, we can then open the Start menu and start typing to find the shortcut of the batch file. And then if we want, we can pin it to the Start menu, and then we can even resize it and fit it in with all of our other programs. And then, just as a demonstration, let's start up GD and press the key combination and see if it works. So remember, I set it to Ctrl, Alt, and G, so I'm going to press those keys right now. We can see that a terminal flashed up on screen for a little bit, and now if we open up Task Manager, we should see that Geometry Dash's process priority is set to high. And you can see it is already set to high. If I hadn't run that script, it would have been at normal, because that's where a process priority is always set when a program is freshly launched. So the batch file did its job, and we now have an easy system to increase Geometry Dash's process priority and make it have a little bit more edge to it when it comes to the CPU. And if you remember, that seems to be right where Geometry Dash is bottlenecked, in single core CPU performance. Now let's transition over to Linux and look at the things we can do to improve performance here. Again, don't forget that setting changes in Steam do not transfer between operating systems, so you can still add or remove the FPS counter and optimize your Steam library for performance. Anyway, our focus here on Linux will be on troubleshooting vertical sync and a program called Game Mode. Also, we're only going to be covering X11. My NVIDIA GPU is old enough that I will probably never be able to use Wayland on this system, so I'm unable to do any testing on Wayland at this time. Also, if you're wondering why we aren't covering power plans like with Windows, the default on Linux is usually just to increase the performance up to whatever is demanded by programs on the system. If we open up the terminal and run this command here, then it'll show us how the kernel is managing the CPU, and we can see that in all locations, the CPU will ramp up on demand. I'll leave this command in the video description in case you want to check it on your system. So let's dive into vertical sync. The first issue that some players will experience with vertical sync is that GD still runs at 60 FPS even though it's on a high refresh rate display. You can see from my FPS counter here that this is happening on my system, as I do have a 120Hz screen. There are two possible causes. First, the high refresh rate monitor could be running at a lower refresh rate. If I open up my display settings, we can see that my display is actually configured to run at 120 Hz. So that's not the problem here. And this brings us to the other cause, and that is that there are multiple displays. You can see I've got two displays here. On Linux, GD tries to match its frame rate to the slowest display, so the 60 Hz monitor to my right is preventing the game from running at 120 FPS. To address this, we need to turn off all but the high refresh rate display in the operating system so that GD only sees one display. Now, I will mention here that there is a way to fix this without having to shut off monitors, but I have never tried it because my GPU is too old to support it. There is a project called GameScope that can fool programs into thinking that the display's refresh rate is whatever you tell the game. Think of it kind of like the Pi Pass, because you can use it to spoof your refresh rate as high as you want. Anyway, I just wanted to mention this as an option, as it can be used to get around this problem. The fastest way to shut off other monitors is to press Super, also known as the Windows key, and P at the same time, and that will usually bring up a menu to quickly manage displays on most desktop environments. Here you just have to choose to use a single monitor, in this case the laptop screen since that's the 120 Hz one. Now I'm not going to do that right now because I don't want to mess with my configuration while recording. However, this can sometimes make the high refresh rate display start running at a slower refresh rate if your previous display settings are forgotten, so then you would have to open up your display settings again and change it back to the high refresh rate. Therefore, the best option is to use the command line and set a keyboard shortcut to run the appropriate commands to manage your displays. The command that we're going to use is xrandr. If you quickly run this command, you will see that it gives you information about your displays. So if we ignore the first line here, every single line is a display. So here we've got VGA0, that's a display that's connected, and then we've got some disconnected displays, and then we've got DP1, which is connected, and then we've got DP2, which is disconnected. Now underneath these displays, we can see that we've got information about what the displays are capable of. So in this first column, we have all of the resolutions that the monitor can run at. So VGA0 can run at a variety of different resolutions, while DP1 can only run at one resolution. And then in the subsequent columns, we have the refresh rates that are available for that resolution. So you can see that VGA0 for the most part can just do 60 Hz, although at a lower resolution it can also do 75 Hz. Meanwhile, DP1 can do 4 different refresh rates, including 120 Hz. The asterisk here indicates what it's currently set to. So you can see that I've got it set to 120 Hz, and for VGA0 I've got it set to 60 Hz at 1920 by 1080. So now that we understand the output of the xrandr command, we can also use this command to control how the monitors are configured. And I'm going to go over the command that defines the current configuration of my system and explain how each of the parts work. So we start off by typing xrandr, and then we do the -- output option, and that's going to specify a specific monitor. In this case, I'm going to specify DP-1, and that's the same monitor that we have here. This is my laptop's main screen. And so for this, we specified this output, and now every option that we include is going to apply to that output, that specific screen, until I specify a different one. So DP-1 we want to set as the primary monitor with the primary option. And then we can also specify the mode, and this is going to be the resolution. And we're going to set the same resolution that we see here, so 1920 by 1080. And it looks exactly like you see it in xrandr's output. And then we can also specify the rate option. And again, we're going to use exactly what xrandr has provided us, so that's going to be 19.97. Now that this monitor is configured, we need to go on to the next monitor. So we're going to specify the output option to choose VGA0. And then we don't want to set it as primary because we've already done that for DP1, so we'll just jump straight to the mode. And again, we want 1920 by 1080. And then for rate, we want 60. So we'll do the rate option. And again, we'll type it out exactly as we see it inside of the output. And now we can do another thing, and that is we can adjust the position with the position argument. And here I want to do 1920x5. Now what this does is it's going to set the top left pixel of VGA0 1920 pixels to the right of the top left pixel of the primary monitor, which is DP1. So that's going to place VGA0 directly to the right. And then with this 5 here, it's going to drop it 5 pixels down. The reason why I want to drop it 5 pixels down is so that it catches my cursor up here at the top. You can see how my cursor bumps into an invisible wall here at the close button. This is to emulate behavior that exists on Windows. If you weren't aware, on Windows there is a 5 pixel barrier in each corner of your screens, making it easier to hit things like the close button or the taskbar down here. Now, I don't really care about the taskbar. I've got a nice big show desktop button, which Windows doesn't have. It's a very thin sliver of pixels. But I do care about the top right here. And so I've just recreated that feature by shifting my other monitor 5 pixels down. And it really isn't a big deal. Anyway, for my system, this is the command that I use to set up my displays in their normal configuration, and I actually have it bound to a keyboard shortcut in the event that I need to quickly correct how my displays are behaving. Let's say, for example, I need to unplug a display for some reason. That will sometimes happen with a laptop. Maybe I need to pick it up and take it somewhere else. I want to be able to adjust how my displays are displaying. So now let's look at a command to disable the slower refresh rate display. What we'll do is we'll erase everything that we don't need, but we still need to specify this output. We need to give it the off option, and that will, of course, turn it off. If you have a high refresh rate display open, and have GD open, and have vertical sync enabled, then GD will immediately jump from 60 FPS to whatever FPS matches your monitor after running this command. So let's open up GD real quick. We can see it's at 60 FPS. I will run this command. The display to my right will turn off. And after it sorts itself out, GD is now at 120 FPS, just like that. Now I just want to quickly give an example of how you might use this xrandr command more practically. If you're using KDE, you can open up the settings and then go to the keyboard shortcuts section, go to custom shortcuts, and here you can set up a custom shortcut to manage your displays. So for example, here I have under the refresh displays folder a bunch of different shortcuts that allow me to manage my displays. So one of them is monitor switch, and all this really does is it runs the script automatically to detect new displays, because I'm using a laptop, so I'll change my displays every so often because the laptop goes places. But I also have in this script an option to set it specifically to use 2 monitors and specifically to use 1 monitor. And this is the idea that I've just showed you. So if we take a look at that script real quick and go down to the solo section, you can see this is the exact same command that I showed you. Now, you can run this command on its own. I needed to run it in a script because I have to deal with my touchpad. My touchpad decides to change how it behaves depending on how much screen real estate I have, and so I needed an extra command to deal with that. But if you don't have that issue, all you have to do is run this one command, and you can put that inside of the command/URL section of the keyboard shortcut. Now, if you're using a different desktop environment, let's say XFCE, it's a similar process. Now, if you're not using a desktop environment, or it just doesn't have that sort of feature built into it, then you can use a program called xbindkeys instead. And that's something that you'll configure in a text file, and you'll want to have it running at startup and just have it running constantly on your system. And you'll probably set up a whole bunch of hotkeys using that program as you build out your system and make it generally more useful. Now, there is another issue that players can run into after they get GD to run at a high frame rate, and that is that the screen itself, despite being set to use a high refresh rate, still looks like it's running at 60 Hz. Even worse, there can sometimes be a lot of screen tearing involved, which is what vertical sync was supposed to fix. This is actually not caused by the display or GD, but by the compositor that applies visual effects to the desktop environment. While you can usually make the compositor run at a higher FPS, you'll most likely get better results just turning it off while you're gaming. Also, turning off the compositor tends to increase FPS because your system will have one less layer of graphical processing to do. In fact, because of the tearing and performance concerns, some Linux native games turn off the compositor as they start up, at least when it's possible to do so. Some desktop environments, such as GNOME, Cinnamon, and Mate, don't allow you to disable the compositor on the fly. However, KDE and XFCE do. For this video, I'll discuss what I do in KDE and link a resource that you can use for XFCE. On KDE, you can turn off the compositor by pressing Alt, Shift, and F12 at the same time. And you can actually see when that happens because here on the taskbar, suddenly all of the icons take up a little bit more space. Now, immediately GD should look like it's actually running at a high frame rate, and if vertical sync failed to address screen tearing, now you might be able to play tear-free. Now, obviously, OBS isn't going to pick up screen tearing or refresh rate, so I can't really show you that, but you should be able to see it when you turn your compositor off. Now that same key combination, which again is Alt, Shift, and F12, will also turn the compositor back on. And you'll probably want to turn it back on when you're done playing because many of the visual effects that your desktop environment has rely on the compositor. For example, these are effects like window transparency. When I drag this window around, you can see behind it. Another example effect is the shadow on the window. There is a faint shadow here, and if I turn off the compositor, you can see the shadow immediately disappears. And yet another example of an effect is this little thing, which helps you find a lost cursor. Now let's talk about game mode on Linux. Linux does have a game mode, but it's not built into the operating system. Instead, you have to download it using your distribution's package manager and then apply it on a game-by-game basis. So if we open up a terminal and zoom in here, the way you download game mode on a Debian-based system is with the command sudo apt install game mode. Now I already have it installed here, so I'm not going to run this command. But if you want to do it on a different distribution like Fedora or Arch, for example, then you're going to have to use a slightly different command because those distributions use different package managers. The package name should be game mode or game mode run. Now, once you have game mode installed, you'll be able to use the command game mode run followed by the command of whatever game that you want to start, and it'll start up with game mode. Now, of course, most of us don't run games through the terminal, so you can instead add game mode to GD using Steam's launch options. To get to the launch options, go to Geometry Dash, and then click on the gear icon, and then click on Properties. This text box here is where you can specify launch options. So to use game mode, you'll type in game mode run %command%. And this will launch Geometry Dash with game mode when you click on the play button. So you can just close here and then click on the button to launch GD, and it will be running in game mode right away. In my personal experience, I have seen game mode even reduce screen tearing in some games, so it's something that I highly recommend. Now, if you're wondering why we couldn't just use the Steam launch options here on Windows, the reason is that the launch options are implemented differently on Windows. On Windows, the launch options use a shortcut file, which can only point to a single executable. Of course, inside of Steam, we can't change the base executable that the shortcut file under the hood points to, so while there are workarounds, they won't function inside of your Steam library. This is why we could not include the process priority script inside of here, which we covered earlier in the video. On Linux, however, it's basically just a command line, so you can run whatever you want. And because we can do anything in the launch options that you can do in a terminal, we can use the launch options to eliminate the need for hotkeys. Here's an example of how to do that. Since I made a script for handling monitor changes, I'll start by running that script with the single monitor option, and then I'll place a semicolon to end the command, and then I'll add a command to disable the compositor on KDE. Now we'll add a semicolon, and then GD can be started, but we need to do so with game mode. So we got to do game mode run %command%, and then we'll put in a semicolon to finish off that command. Now, once GD closes, this command will be done, and then we can do everything in reverse. So we'll want to turn the compositor back on. So I'll copy and paste that command in here, and then we will set the displays back to how they were. So we'll put in our semicolon and paste in our command to the script that I wrote. And so now that that's done, then we should be good to go. So let's close this out. One thing I do want to note here though is that when you run the command to disable the compositor in the terminal, so let's open that up and let me show you an example, a notification is going to appear down here. Now this doesn't happen with the hotkey. What you can do if you don't want to see that is you can click on the settings icon and it will open up a set of dialogues for dealing with notifications for KWin. And here we've got the compositing has been suspended option, and we can just uncheck this so it no longer shows a pop-up. So we'll hit apply, we'll click on OK on both of these, and now let's resume it real quick, and you can see that it will not come up. So now we'll paste that in, and we've turned off the compositor once again, but no notification. So let's turn it back on real quick, get back to normal. Alright, so now, again, we have finished configuring all of the launch options for GD. So we are running 5 commands. We are configuring the displays. We are turning off the compositor. We are launching Geometry Dash with game mode. And then we're turning the compositor back on once GD closes, and then we're setting the displays back to normal once GD closes. So when I click on this play button, all of that's going to happen. So Steam's going to take a bit to prepare GD, but in just a little bit, we're going to see all of that I just described happen. There's the display change. There's the compositor turning off. And now GD is starting. And you can see GD immediately went to 120 FPS. And now when I close it, there the compositor turned back on. And the displays are flashing, and now I've got my other monitor on. And that's it. Everything I explained in the Linux part of this video has come together, and it all just works when GD is launched. Of course, I still recommend having hotkeys available for monitor and compositor management, but the end result here on Linux is actually very convenient and easy to use. And that does it for this video. It has been a long one, but hopefully you have a better understanding of how GD works and how to get the most performance you can out of it. Let me know what you think in the comments below. Is there something I could have explained better? Did I get something wrong? Let me know. And I will see you guys later in the next video. Bye.